Hello, I'm Angelo, and in this tutorial we will learn how to read, summarize, filter, manipulate, and visualize tabular data in R. The main goal is to develop practical skills for handling datasets, preparing them for analysis, and eventually applying them in predictive modeling. We will walk through the workflow step by step, starting with loading data into R, then moving into exploration, cleaning, transformation, and visualization. We begin by reading tabular data into R. In the homework, you will use the Superstore dataset, but here I'll use the Palmer Penguins dataset, which contains biological measurements for 3 penguin species. I'm running this tutorial on Google Colab, but you can use other environments like RStudio or VS Code. If you want to use Google Colab with R, you need to change the runtime. So click on runtime, change runtime type, and under the language option, just select R and save the changes. Here, I'm importing a package mainly to use the pipe operator. The pipe operator allows us to chain multiple operations together sequentially instead of nesting function calls inside each other, which quickly becomes unreadable. The pipe makes code cleaner and easier to follow. So in practice, this makes feel like we are describing a workflow in natural steps, but we'll see a concrete example later. Next in this line, I installed the Palmer Penguins package, which contains the dataset we will use for homework. However, you'll practice using the read CSV function to load your dataset from a CSV file. And remember, the datasets can come in different formats, and R provides multiple functions to load them. But yeah, for this particular homework, you only need to use this read CSV function. Whenever you load a dataset, the first step is exploration. Some useful functions include the head. So in this particular case, this function shows the first 3 rows. This is useful for quickly checking the variables, the columns, and the structure of our observations, which are the rows. The other function that we can use is the tail. The tail shows the last n rows, in this case, just only 3. This is especially handy for time series data, where you can care about the most recent entries. And lastly, the str function. This function provides a compact summary, like the number of rows and columns. In this case, 344 observations and 8 variables or columns. The variable names, which in this case are this one, species, island, bill length, bill depth, and so on and so forth. And the types, numeric, integer, factors, etc. And a sample of values. It is also highlights the missing values, which are in here are declared as NA, and this is stands for not available values. So the conclusion here is always check the structure and the presence of missing values before analyzing. For more details, we can use the dim function, which returns the number of rows and columns. So we have 344 rows and 8 columns. We can use also the n row and n column functions to get these same values but separately. And the names function to get the names of the columns. And summary, this function produces descriptive statistics like the minimum value, the maximum value, the mean, the median, and the quartiles. And this is exactly the same statistics for all numeric values in our um, variables, but for categorical variables, we can have in this summary just only the counts per category, like for example here in the species. Uh, Now let's talk about the missing values. Missing data is inevitable in real world data sets. So we can use this a function here is that .ni, and we can put inside the data frame which contains our data set to find where values are missing. And also we can use like for example this sum function to uh, take an idea about how many missing values we have in our total data set. We can also use this another function called sums to break it down per column. So for example in here we have 0 missing values in the species column, and for example in here we have 11 missing values in our sex column. So the simplest way to handle missing values is just only remove them. So using this omit function, we can do it. It's not always the best option, but it's a quick way to get a clean data set. So after removing, you can verify again the sum of the entire data set about the missing values, and we can get this 0 value here. So notice that now we can work with our clean data set, which is stored in this variable now, df and a. Regarding to data filtering, we can apply some filters to our data set to gain specific insights. So for example, we can retrieve the penguins of a particular species from a specific location and merge them into one unique data frame using this rbind function. Here we use the pipe operator. So this is a workflow. First, we state that all subsequent code is based on this df and a data frame, and then we apply a filter to that data frame. We can achieve the same result using this different approach, but an important point to notice is that in the pipe operator approach, we don't need to specify where each variable comes from because we establish that from the start that we are working with the df and a data frame. However, with the alternative method, we need to specify where each variable comes from. For example, in here, the species, we need to specify that this variable comes from df and a data frame. So the results are the same, so use the approach that is most comfortable for you. Here the same thing, so to get the mean and the median, just use the proper functions. Here we are saying that, okay, take the body mass of our variables, which is this column here, and from those columns we are filtering those that belong to the male in our sex variable. I added this extra option just to show the functionality that enables us to remove the missing values. However, in this case, it is redundant because we already did it for the entire data set, and a similar explanation applies for the median. We can make different kind of plots, like the box plot, for example. So in here you can customize the title of your plot and the axis also. We can also do some histograms like this one, and there are a bunch of different graphical representations of your data that you can make. Regarding to the creation of new features or variables or columns, all these are synonyms. Again, you can do it using the pipe operator or not. In this example, I'm creating a Boolean variable called mass1.flag. That is true if the body mass is greater than 4,000 and false if not. And the other new variable that I'm creating here is this u1.ratio, which is equal to the build length divided by the flipper length. Again, you can use the pipe operator approach, or you can do it using this alternative code. Lastly, to finish this tutorial, some statistical calculations. So I'm taking the flipper lengths only as our values, and I am calculating the mean, the median, the standard deviation, and the quartile. This code in here calculates the 25th and the 75th percentiles, also known as the first and third quartiles of the values vector. So the meaning of this is that the first quartile of the flipper length is 190 and the third quartile is 213. This tells you that the 25% of the penguins have flipper lengths less than or equal to 190, and that the 75% have flipper lengths less than or equal to 213. So that's it. Thank you for your attention.